Hello everyone, in this video we will go over section 6.2, which is volume. There are two methods to find the volume. We're gonna focus right now on the disk method, which is sometimes just called the washer method because the rotations look like washing machines. So the idea is pretty simple. So you're gonna have a function, any function. Let's say this is f of x, and then you're gonna have an interval. Let's say you go from a to b. So you already know how to find the area. So to find the area, remember it will be the integral from a to b of the function. So that's what we did in the last section and also in calculus 1. All right, so now what we're going to do is to create volume. Since the area is in 2 dimensions, you're going to rotate this, and the rotation could be on the x-axis, the y-axis, or a different line in here or in here or even here. Okay, so for now, let's say that we are rotating on the x-axis or around the x-axis, but remember you can rotate in different positions. Now here the idea is we're going to use the area for a circle. Remember, you have a circle and you have a radius r, and the area is equals to pi r squared. Why is this important? Well, notice that if you rotate this around, you essentially create a bunch of circles. Okay, so you'll get a bunch of circles around it. So you will have like one circle here, another circle there, and so forth. Okay, where the radius is going to be related to the function. Then if you add all the areas of the circles, well, then you will get the volume. So that's the idea. Now here we're going to use something that's called a partition. So the partition will be something like this, which is technically, in our case, is going to represent the radius. So this will be the radius of the circle. Notice how the radius changes depending on the value of the function. So here you will have a circle that looks like this, here another circle that looks like this, and this is where the washer method name comes from, because this will look like a washer machine to some degree here. Now the important part for this method, for the dish or washer method, is that the partitions, which in this case this is the partition, which remember is technically the radius, must be perpendicular, so this is important, to the axis of rotation. So again, this is very important. All right, so let's get more specific on this. If you look closely to this function, this is technically x squared, and let's say you go from 0 to 1, so you want to find the volume if you were going to rotate on the x-axis. Okay, so here the partition, remember, has to be perpendicular. So this is the partition, which, like I mentioned earlier, this is essentially just the radius. Okay, and then if you were going to do a bunch of circles around it, the graph will look like this when you are rotating. It should look something like this. So you can see here you will have one circle, another circle, another circle, and so forth. So therefore, remember that the area is equals to pi r squared from here. So therefore, if you were going to add all the areas, it's going to give you the volume. So the definition is going to be the following. The volume will be the limit as n goes to infinity of technically the summation of all the areas. Okay, so all the areas times delta x. But notice that this is nothing more than just the integral from a to b of whatever the area function is. So if you integrate all the areas, well, you will get a volume. So in our particular case, the area is defined as, remember, pi r squared, where r is technically the function, or the radius is the function. You can see that from here, the radius keeps changing with the value of the function. So therefore, technically, this is what you will call the radius. So in our case, if we use the formula for the circle, this will be just the integral from 0 to, or from a to b, this is in general still, of pi times r squared. So now in this particular example, this will be the area from 0 to 1, because we're only going from 0 to 1, of pi times x squared. So the radius is x squared, so it should be squared. So therefore, you can take pi out. This is the integral from 0 to 1 of x to the 4 dx. And this will be just pi over 5 times x to the 5 from 0 to 1, which is equals to 1 over 5 pi, and this will be cubic units. And that's it. All right, so let's try another example. Here, it's important to recognize that this function is just the square root of x. So therefore, remember the area as the function of x is pi times the function, which is the radius, square. Okay, and here we have, this is a partition. Let's say we're rotating again on the x-axis, and let's say we go again from 0 to 1. Okay? So therefore, the volume is going to be the integral from 0 to 1 of pi times r, which is radical x squared dx. And then this is just pi, goes outside. This is the integral from 0 to 1 of x dx, which the integral of that is pi, x squared over 2. And you go from 0 to 1. This is going to be just pi over 2. And the volume is always measured in cubic units. So you can see that's pretty simple. Okay? Now, note, so this is an important note. Let's say that instead of rotating around around the x-axis, that you were going to, let's say, rotate around, let's say, y equals to -2. Now, notice that the line y equals to -2 is somewhere here, okay? So let's say y equals to -2 is here. So if you were going to rotate here instead, then notice that the radius is not this anymore. It's this plus all of this. This will be part of the radius. But notice the distance between here and here is 2. So therefore, if this was the case, the formula for the volume is going to be still 0 to 1. You still have pi. But now the radius is going to be the square root of x, which is the distance between here and here, plus this distance, which is 2. So this will be square root of x plus 2 squared dx. And then you just do the integral, which is pretty straightforward, and that will be the volume. So this is as complicated as this thing is getting for now. So when you don't rotate on the x or the y axis. Okay? Now, let's look to an example where now you have two functions instead of one. So here, you should recognize that this is, again, x squared, and this is the square root of x. Okay, so those are the two functions. And let's say that we're rotating on the x-axis again. Remember, the partition has to be perpendicular to the axis of rotation. So it should be here. And now the difference is that the radius, or the new area formula, is going to be this. It's going to be still pi, but now the radius is going to be the upper function square minus the lower function square. So this is the difference. Okay, so this will be the new thing. Besides that, it's identical to the previous one. So therefore, if you are rotating on the x-axis, the volume for this particular problem is going to be the integral from 0 to 1, because remember these two intersect at 1. I believe we solved this in the previous lecture. So this should be pi. The upper function is radical x. I'm going to square that, minus x squared dx. Then if you do a little bit of algebra, this is pi, the integral from 0 to 1 of x minus x to the 4 dx, which this is pi times x squared over 2 minus x to the 5th over 5, and this is from 0 to 1. And you should check that this is just 3 pi over 10. And that's in cubic units. And that's it for that. All right, so now let's try some examples that are a little bit more tricky. We haven't done any where you rotate around the y-axis, so let's do that right now. So first, let's graph these two equations. So let's call this one equation 1 and this one equation 2, okay? And let's say that I want to rotate around the y-axis, okay? So first, let's do the graph for this. The first one, you should check, let's say this is the origin. So the first graph looked like this. So this, guys, something like that. And the other one, it's going to look like this. Okay. The important part here is that they intersect here and here, and you should check that by just simply doing the intersection. So you do the intersection. Remember, that means that 2 minus y squared should be equals to y to the 4. So you have 0 equals to y to the 4 plus y squared minus 2. And then you can factor this as y squared minus 2. And then y squared plus, actually this is plus 2 and this is minus 1. Notice that this one has no solution, and the answer to this one is y equals to 1 and negative 1, which is here 1 and negative 1, so that's where they intersect. All right, so this is the area that this is where you want. Remember, we are rotating around the y-axis now, and therefore the partition, remember, has to be perpendicular to the axis of rotation. So this is the radius, okay? So therefore, in this particular case, then the volume is going to be pi, the integral from -1 to 1. The upper function, remember this one is x equals to y to the 4, and therefore this one is 2 minus y squared. So the upper one is that 2 minus 1 square, and the lower bound is lower one is y to the 4 square. The whole thing is dy. If you do the algebra here, so this is minus 2, 1. This is actually just 4 minus 4y squared plus y to the 4 minus y to the a. This is very, very, very easy to integrate. So this will be pi times, this will be 4y minus 4y cubed over 3 plus y to the 5 over 5 minus y to the 9 over 9. And then just plug in the limits of integration, and that's it. So just make sure that you verify this. Okay, so just check the final answer. Now notice that in this question, if I would ask you to rotate on the x-axis, that would have made the problem a little more tricky because this function is exactly the same function. So you would have to cut it in pieces, and that would have made the problem much complicated. So for this particular example, rotating about the y-axis is probably the easiest way to do the problem. All right, so let's do one last problem. So here you need to do the graph first. Let's say this is pi over 4. This is pi over 2. And let's say this is 1, so therefore minus 1 is somewhere here, okay? So let's say first you want to do the graph for sine. Remember, the graph of sine looks like this. When it gets to pi over 2, it becomes 1, and then it keeps going this way because you're only going from 0 to pi over 4. So you're only doing this much, 0 to pi over 4. Now the graph of cosine, on the other hand, starts in 1, and then it goes down until it gets to 0 here. Then it keeps doing this. But since you only went from 0 to 4, essentially you only want this area, okay? So clearly you can see that the sine of x is the upper one and cosine is the lower one. Then this one you are rotating on the line y equals to -1. So we are rotating here. So therefore the partition has to be perpendicular to the axis of rotation. So the partition has to look like this, which is perpendicular to this part. Okay? Then we have to figure out where the radius is. So remember, the radius for now will be the distance of the two functions. But since we're not rotating on the x-axis, we're rotating here, you had to add this much to the distance or to the radius. So therefore, the volume is going to be pi, the integral from 0 to pi over 4, because that's where they intersect. The upper function is going to be, the upper function is actually cosine. I have this backwards, so let me fix that part. This is actually the graph for sine. This is the graph for cosine. So sorry about that. I have this backwards. This is cosine of x. This is sine of x. So therefore, this is going to be cosine of x plus 1. The plus 1 is, again, to compensate for this distance. And then it should be square. And then minus the lower one, which is sine of x plus 1 square. Okay. Then you just have to do a bunch of algebra here. So you do that, you end up with the following. This will be cosine square x plus 2 cosine x plus 1, and then minus sine square x minus 2 sine x plus minus 1 dx. And then here, the ones that can cancel are the 1 cancels with the minus 1. Then notice that cosine square minus sine square is an identity. So recall this. Recall the cosine squared theta minus sine squared theta is the same thing as cosine 2 theta. Okay, just remember that from your trig skills. You also should have seen that in calculus 1. So then this is going to become pi, the integral from 0 to pi over 4. The two green parts combined becomes cosine of 2x, and then plus 2 cosine x minus 2 sine x dx. Then to integrate this is actually pretty simple. The integral of cosine 2x is 1 over 2 by using the substitution sine of 2x, and then this is minus 2 sine x, and then minus 2 cosine x using the antiderivatives, and this goes from 0 to pi over 4. So whatever this is, you should just check that. And that's it.